Okay, this is Unit 8, Day 3, and this is going to be Part 2 of our notes. We already finished the front of our notes here, and now we're going to work on the back of our notes. And this is what is called coordinate geometry, because we're going to look at actual coordinate planes where I've already plotted the points for us. And there's basically 4 methods here that we can use with a coordinate plane. And I just want to show you that these are the same ones that we were looking at over here on this page. The first one says the diagonals bisect each other. Was that one of our choices here? It's right here. The diagonals bisect each other, then it's a parallelogram. In order to show that on a graph, we show that the midpoints of the diagonals are in the same location. The second one here is show that the opposite sides are parallel. Well, that's literally our definition here. If opposite sides are parallel, then we know it's a parallelogram. And we do that by showing that it has equal slopes. Remember, if they're parallel, the slopes are the same. The third side is both pairs of opposite sides are equal distance or a Pythagorean theorem. So we're saying that the opposite sides are the same length. Well, here, that's this rule right here. If opposite sides are congruent, then it's a parallelogram, so that's the same thing there. And finally, one pair of sides is both parallel and congruent. That's just like this rule right here, where both sides, where there's one set of sides that's parallel and congruent, and we would show that they have the same slopes and they have the same length. So I'm going to show you how each one of those works here. Our first example is we're going to show that opposite sides are congruent by using the distance formula or our Pythagorean theorem. Remember, we had the distance formula a couple of days ago. Distance equals the square root x1 minus x2 squared plus y1 minus y2 squared. Or we can use Pythagorean theorem, a squared plus b squared equals c squared. Both of these work exactly the same way. You can use either one you want. Also, if it's just horizontal, I don't really need to do that because I can just measure the squares there. So I graph these 4 points, and I want to show this makes a parallelogram. So I'm going to label these A, B, C, D. I want to show that AB is the same length as CD. Well, AB, I don't have to use one of these formulas because I can just measure it. 1, 2, 3, 4, 5, 6. And CD, I can measure this one. 1, 2, 3, 4, 5, 6. So those are the same length. This one is the same length as this. Now I can use Pythagorean theorem on the other ones. I'm going to do this one right here. It's 2 and 1, 2, 3, 4, 5. So for AC, a squared plus b squared equals c squared. This side is 2. This side is 5. So that's 4 plus 25 equals c squared. 29 equals c squared. And then to get just the length of this side here, I take the square root. Now if I do the same thing on this one here, it's also 2 and 5, so I'm going to get the same length. So AC is equal to BD, and they're both equal to the square root of 29. I can leave it like that, or I can just use my calculator and do the square root of 29, and I'll get that it is 5.385. Alright, so the next one I want to do is this one here. I have a different quadrilateral, and this time they want me to show that it's parallel by showing that opposite sides are parallel. So I need to use slope. And let's write down and remember what slope is. Slope is going to be our rise over run. Or we can use our slope formula, which is y2 minus y1 over x2 minus x1. But I think especially if we have a graph, rise over run is just easier. So let's again label this A, B, C, D. AB, its slope is rise 2, run 3. BD is rise 1, 2, 3, run 1. CD is rise 1, 2, run 1, 2, 3. and AC is rise 3, run 1. So I've shown that these sides here are parallel because they have the same slope, and these here are parallel so they have the same slope, and I'm going to mark that on my picture. And finally, I'm going to do one where we show that the diagonals bisect each other, and remember over here it says to show that using the midpoint. Remember that to find midpoint, it's just x1 plus x2 over 2 and y1 plus y2 over 2. So I'm going to show that those are in the same location. A, B, C, D. So AC is right here. I'm going to find the midpoint of AC, so my x1 and x2 are 3 and 0. And my y's are 2 and negative 2. So 3 plus 0 is 3 over 2, 3 halves. And 2 plus negative 2 over 0, well, that's 0 over 2, so that's 0. And now let's find the midpoint of this one. BD, well, its x's are negative 3 and 6, and its y's are negative 2 and 2. So negative 3 plus 6 is 3 over 2, and negative 2 plus 2 is 0 over 2, so that's 0. And these two both have midpoints right there. I didn't draw it very straight, but their midpoints are both right there. So I've shown that they have the same midpoint, so they bisect each other.